Today's number 28 most urgent vulnerability is CVE 2026-71558 in Apache Fory, and it earns a deep dive because it sits at the intersection defenders do not like: deserialization, C++, type confusion, and a 9.8 critical CVSS score. This is the Daily Ranked CVE Brief, What to Patch First, ranked by real exploitation signal from CISA-KEV, First EPSS, and CVSS, every day. This one is not currently listed in CISA's known exploited vulnerabilities catalog, but the impact is serious enough that exposed teams should not ignore it. A crafted input payload can cause Apache Fory C++ to treat one object type as another during polymorphic smart pointer deserialization. In plain English, data that your application is trying to rebuild into objects may be accepted as something it is not. The stated outcomes are denial of service or potentially arbitrary code execution. Apache Fory is the affected product, specifically the C++ implementation according to the published description. The vulnerable area is deserialization, the process of taking stored or transmitted data and reconstructing in-memory objects from it. The weakness is tagged as CWE-502, deserialization of untrusted data, and CWE-843, access of a resource using an incompatible type, commonly described as type confusion. The key phrase is polymorphic smart pointer deserialization. Polymorphism means code can work with a base type, while the actual object underneath may be a derived type. The advisory description says a crafted input payload can bypass type compatibility checks, causing an object of an incompatible type to be treated as the declared base type. That is dangerous because C++ programs rely heavily on object layout and type assumptions. If those assumptions are violated, behavior can become undefined. Score verdict. This is a critical, remotely reachable bug, where the worst-case impact covers confidentiality, integrity, and availability. The CVSS vector is 9.8 critical, AVN, ACL, PRN, UIN, with high impact for confidentiality, integrity, and availability. The two things that matter most for defenders are reachability and privilege requirements. Network attack vector means the vulnerable condition can be triggered across a network path if the affected deserialization functionality is exposed to incoming data. Privileges required is none, and user interaction is none, meaning the score assumes an attacker does not need an account and does not need to trick a user into clicking something. The second key point is impact. High confidentiality, high integrity, and high availability means the theoretical worst case is not just a crash. It includes data exposure, data modification, and service disruption. Now the exploitation signal. This CVE is not currently on CISA's known exploited vulnerabilities catalog. That matters because KEV status is one of the strongest public signals that exploitation is happening in the wild. So, this is not a KEV-driven emergency in the same way a confirmed exploited vulnerability would be. The EPSS percentile provided is 0.50307, which does not place it at the very top of today's exploitation probability signals. But that does not make it safe. The reason this still ranks today is the severity and the class of bug. Deserialization vulnerabilities become especially dangerous when applications accept serialized data from outside a tight trust boundary. If Apache Fory C++ is used only on trusted internal data that never crosses user or service boundaries, risk may be lower. If it processes untrusted, semi-trusted input, the priority rises sharply. Conceptually, the attack path starts with data reaching an Apache Fory C++ deserialization routine that uses the affected polymorphic smart pointer behavior. There is no need to discuss payloads or exploit mechanics to understand the defensive issue. The application receives serialized data, passes it into Fory, and Fory attempts to reconstruct objects from that data. The vulnerability description says crafted input can bypass type compatibility checks, so the application may end up operating on an object as if it were a different declared base type. From there, the outcome depends on the application, the surrounding memory layout, and what code paths run after deserialization. In the lower impact case, the process may crash or become unstable, creating denial of service. In the more serious case described by NVD, undefined behavior may potentially lead to arbitrary code execution. The key defensive question is, can untrusted input reach that deserialization path? To check exposure, start with inventory. The NVD description says this issue affects Apache Fory C++ versions from 0.14.0 before 1.5.0. Users are recommended to upgrade to Apache Fory 1.5.0. Treat the vendor advisory as the source of truth for exact applicability, and verify what is actually built and deployed, not just what is declared in a repository. Look at dependency manifests, build files, lock files, SBOMs, container images, and statically linked components where relevant. Then answer the functional question: does the application use Apache Fory C++ polymorphic smart pointer deserialization? The description is explicit that applications not using that feature are not affected. Finally, map data flow. Identify which services deserialize Fory data, where that data originates, whether it crosses API, message queue, file upload, RPC, or inter-service boundaries, and whether any of those sources are untrusted or only partially trusted. The primary fix is straightforward. Upgrade Apache Fory to 1.5.0, which the description says fixes the issue. For C++ dependencies, remember that patching may require more than changing a version string. Rebuild affected applications, refresh containers or packages, redeploy services, and confirm the running artifact is actually using the fixed library. While patching, reduce exposure around deserialization. Do not deserialize data from untrusted sources unless the application design truly requires it. Put strong validation and trust boundary controls around any serialized input path. Where your architecture allows it, restrict which services can send serialized Fory data to the component that consumes it. Add regression testing around polymorphic deserialization behavior so future changes do not silently reintroduce risky assumptions. If immediate upgrade is delayed, prioritize compensating controls on internet-facing, partner-facing, or cross-tenant data paths first. For detection and monitoring, focus on the systems where Fory C++ deserialization is actually in use. Normal should look boring: stable success rates, predictable data producers, predictable object types, and no unexplained process instability around deserialization workflows. Watch for spikes in deserialization failures, type compatibility errors, malformed input handling, or application exceptions near object reconstruction. Also watch for denial of service symptoms: crashes, watchdog restarts, memory safety faults, sudden CPU or memory spikes, or repeated failures after receiving serialized data. In distributed systems, compare the source of serialized messages against what is expected. A service that normally receives Fory payloads only from a small internal set should not suddenly see new sources or unusual volume. Because the stated risk includes arbitrary code execution, pair application logs with host-level monitoring. Unexpected child processes, unusual network connections, or behavior that does not match the service's normal role should be investigated. Bottom line: CVE-2026-71558 is a critical Apache Fory C++ deserialization vulnerability with a 9.8 score. It is not listed in sysexhev today, and the provided EPSS percentile is 0.50307, so the public exploitation signal is not the strongest part of the story. The strongest part is the impact. Crafted input can bypass type compatibility checks during polymorphic smart pointer deserialization, with denial of service or potentially arbitrary code execution as stated outcomes. If you run Apache Fory C++ versions from 0.14.0 before 1.5.0 and use the affected polymorphic smart pointer deserialization path, upgrade to 1.5.0 and verify deployment. If you do not use that feature, document the finding and confirm it with engineering evidence. This is the Daily Ranked CVE Brief, what to patch first, ranked by real exploitation signal. Subscribe for tomorrow's ranked breakdown, and see the full ranked report linked in the description.